gates are the basic building block of any digital system. Boolean logics are represented by two states, true or false, or 1 or 0. Before we go on with our discussion, let's discuss first the normally open and normally closed contact. In this example, the bulb is not glow because the contact is normally open or false. The current from line 1 cannot pass through the circuit. In the example number 2, the bulb is now glowing because the contact is normally closed, and the current from line 1 can pass through the circuit going to line 2. Our next topic is buffer. If this is your first time here, please don't forget to subscribe and hit that notification bell so that every time I will upload a new video, you will be notified. And also, check my other video like interview question and answer, hydraulic pneumatic, FANUC robotics, motor controls, and many more. A buffer gate has only single input and a single output. If it receives 0 as an input, the output is also 0. Similarly, when it receives 1 as an input, the output also 1. Our next topic is NOT gate or inverter. The NOT gate is a single input, single output gate, also known as inverter. NOT gate, if it receives 0 as an input, it produces 1 as an output. Similarly, if it receives 1 as an input, it will produce 0 as an output. Our next topic is AND gate. The AND gate gives output of 1 if both two inputs are 1. Otherwise, if one of the input is 0, it will give us an output of 0. Our next topic is OR gate. OR gate gives an output of 1 if either of the two input is 1. It gives 0 otherwise. Our next topic is NAND gate. NAND gate is an AND gate followed by a NOT gate. And this is the basic constructions of NAND gate. The truth table of NAND gate, when A and B are both 0, the output is 1. When A is 0 and B is 1, the output is 1. When A is 1 and B is 0, the output is 1. And when both A and B are 1, the output is 0. Our next topic is NOR gate. NOR gate is an OR gate followed by a NOT gate. And this is the basic construction of NOR gate. The truth table of NOR gate, when A and B are both 0, the output is 0. When A is 0 and B is 1, the output is 1. When A is 1 and B is 0, the output is 1. And when A and B are both 1, the output is 0. Ohm's law is one of the major and fundamental laws of electrical circuits, which states that the current passing through a conductor is proportional to voltage over the resistance. Ohm's law equation. Ohm's law may sound a bit confusing when written in words, but it can be described by the simple formula where I, current in amps, V equals voltage in volts, and R equals resistance in ohms. The same formula can be also written in order to calculate the current, voltage, or resistance. Ohm's law analogy. In this circuit below, the electric current flowing in the circuit. Since we cannot see the current or electron flow, it would be nice if we have water pump flowing through a pipe as our comparison. The mechanical system consists of a pump pushing the water through a closed pipe. Just imagine that the electrical current is similar to the water flowing to the pipe. The pipe is like a wire in the electrical circuit, and the pump is like a battery. The pressure generated by a pump drives the water through the pipes. The pressure is like a voltage generated by a battery, which drives the current through the circuit. The valve or knob slows the water flow, creating pressure difference from one end to the other end. In the same way, resistance in the circuit restricts the flow of current. Ohm's law pie chart. In this example of Ohm's law pie chart, we have a motor connected to a power of 230 volts, drawing a current of 12 amperes. What is the power in watts? We can solve this using formula P equals E times I equals 230 volts times 12 amperes equals 2,760 watts. Then divide by 746 to find the horsepower. Note that 1 horsepower is equals to 746 watts. This is an example of electrical circuit. We have simple circuit, series circuit, and parallel circuit. If this is your first time here, please don't forget to subscribe and hit that notification bell so that every time I will upload a new video, you will be notified. And also, check my other video like interview question and answer, hydraulic pneumatic, FANUC robotics, motor controls, and many more. In our example in problem solving, a bread toaster having a resistance of 75 ohms connected to a 110 volts. What is the current? By using Ohm's law, I is equals current in amps, V is equals voltage in volts, and R is equals resistance in ohms. Our voltage is 110 volts divided by 75 ohms. Our current is 1.47 amperes. In this next example, are 3 pieces lamps connected in series having a resistance of 3, 5, and 9 ohms. What is the total resistance? Since this is series, we just add the individual resistance to find the total resistance. RT is equals 3, 5, 9 ohms. The total resistance is 17 ohms. Welcome to Ohm's Law practical exercise. Here we have a bread toaster with a ratings of 750 watts and 120 volts. And I have here connected in series my clamp ammeter. We are going to prove in our computations if our current is 6.25 amps. And I have a bread here that we're going to toast. And we're going to get the current if the current is 6.25 amps because we have a power in watts, 750 watts over 120 volts. Let's prove it. Now I'm going to switch on the current. 6.18 amperes, so it's almost the same to 6.25. So we are right. When you are going to use a clamp ammeter, do not clamp it in 2 wires. See here, we have 0 current. Let's clamp it in 1 wire. See, our current is 6.22 amperes. Thank you for watching and see you on the next video. If you like this video, please like, share, and subscribe. Have a good one.